Hello everyone. So today we are going to present on web search engine and we are from group number 6. Our team members are Harsh, Vrunda, that's me, and Jimish. So firstly we talk about what is search engine. A search engine is a software system through which users can search internet content. To do this, users enter the desired search term into the search field. A search term is what users key into the search engine when they want to find something specific. A search term can be a single keyword or a combination of words. A keyword is what users write into a search engine when they want to find something specific. A search engine then looks through its index for relevant websites and displays them in the form of a list. Google, Bing, and Yahoo are the popular examples of the search engine. An index is the another name of database used by a search engine. Indexes contain the information on all the websites that any search engine was able to find. If a website is not in a search engine's index, users will not be able to find it. Ranking. The goal for many sites is to appear in the first search engine page result for the most popular keywords related to their business. A site's keyword ranking is very important because higher the rate a site ranks in the search engine result page, the more people will see it. Next is the approach which search engine follows, and we come across three main keywords, which is web crawling, indexing, and searching. First is web crawling. This web crawling is created for indexing the content. They scan and assess the content on the site pages and information archives across the web. These are almost always operated by the search engines. By applying a search algorithm to the data collected by the web crawlers, search engines can provide relevant links in response to the user search queries, generating the list of the web pages that show up after a user types a search into the search engine. Next is indexing. Indexing is a process by which search engines organize information before a search to enable superfast responses to the queries. Searching through individual pages for keywords and topics would be a very slow process for search engines to identify the relevant information. The purpose of storing an index is to optimize speed and performance in finding the relevant documents for a search query. Indexing means associating words and other definable tokens found on the web page to their domain names and HTML-based files. Searching. A user query prompts engines to return the results which are ranked hierarchically using the trust and the relevant signals.
Now let us understand the block diagram of the system that we have implemented. So a user will basically write some keywords, and on the basis of what he or she has written, they will get some suggestions which they can use to complete the autocomplete text view. Now once they press the search button, a web crawler will run. If it is running for the first time, it will crawl the root URL and all the links which are present inside that, and after crawling that, the JSON parser will convert all the HTML stuff to text files, and after converting them, we will find the number of occurrences of the keywords in each file, and we will sort them in the descending order so that we have the URLs with most number of occurrences on the top, and after sorting them, those URLs will be visible to the user. Now if the crawling part has already been done once, then it means that all the text files are obtained, and now we have our local data repository as well in terms of files. So when the next time any search is made, the crawler will not crawl the internet, rather we will find our keywords from the files that we already have downloaded in terms of text files. We have implemented a web application, so in that we have a text view which contains autocomplete feature. So whenever at least 3 characters are typed, then a backend API will be hit, and that will bring the suggestions on the basis of what the user has written, and this we have implemented using the try. After that, the web crawler that we have implemented in Java URLs will be indexed into a hash map. Then TST is generated for each text file and frequency of keywords are extracted from it. To implement page ranking, frequency of these words along with the URL are indexed and stored into a hash map. The page ranking hash map is sorted in decreasing order of the frequency of the words, and here we have used merge sort for sorting. The page ranking hash map is stored in memory to implement caching, and this will drastically improve the search time. Let's move towards the code walkthrough and demo part. We have made the application using Spring Boot and all the Java based technologies. So we have used Themeleaf for rendering our content, and this is the entire package structure of our application. The main loader class is ACC application, from where the application starts. Then we have main controller, which contains 3 endpoints. The first one is just to load the index page. Then the next one is the autocomplete, which will load the suggestions on the basis of characters that a user has typed. And the last one is search. So when a user presses the search button after writing all the keywords, this endpoint is called. We have search DTO, which acts as a data transfer object between the Spring Boot server and Themeleaf rendering engine. Then we have crawler service, which crawls the web and finds out the necessary URLs for us. Then we have try service, on the basis of which the suggestions are decided for the autocomplete text view. Then these are some utilities that we have used as part of our application. And sorting and text processing, which were present in our assignments, have also been used in our project. And once the crawler crawls all the URLs, we will store them over here in this URLs folder. And as of now, we are working with nearly 1200 URLs. Let us have a look at the demo of the application that we have implemented. This is the index page, and if I write COM over here, so we can see that 2 autocomplete suggestions are coming. If I select computing and if I hit the search button, you will be able to see few URLs. And we have also implemented pagination. As of now, only 5 links will be shown in a single page, and all these are accessible. So these are different, as we can see, and these are coming on the basis of the frequency of the keywords. And as of now, we only have one keyword, which is computing. Now let me change and let me write science. Searching for the same. So again we have few URLs, so I'll hit this one. We'll check the occurrence of science in this page, so it's 40 times, as we can see. Now I will go to the second URL. It should be a little bit less than or equal to 40. So if I see that it's 34, or let it load entirely, so it is 33. And the final one is the third one, and here it should be again less than 33. Nope. And so we can see that the number of occurrences of our keywords are decreasing as we go down with each URL. And this is it for the demo part. And guys, one more thing, we have implemented this dark mode and light mode as well. So this is how we can change the views.
Okay, so we have already seen the working demo of the project. Now let's see the collaboration part, how we have collaborated during the project. So for the collaboration, we have used the GitHub, Eclipse for the development purpose. We have used the in-time problem solving strategies, and for the communication, we have always used the Microsoft Teams for the meetings or for the query solving. Followed by that, conclusions and learnings. So some of the important learnings from this project are features, project management skills, technologies, data structures, and memory management. When we say the features, whenever we require something, we always went to the Google or searching something and getting the result in a fraction of seconds. Now, through this project, we got to know actually how it is working from the backend. From the starting of the crawling of the web pages to the caching, we learn all the aspects how we can develop our own search engine. Along with that, we also learned the project management skill with the help of few technologies like Spring Boot, Themeleaf, JSON, etc. Data structures and memory management are two major aspects when we are working with the search engines, because performance optimization plays a major role. When your search engine is not much efficient enough or much faster, then there is no meaning of that. So memory management and data structures are two important aspects of this, which we learn from this project. What will be the future scope for us? So our first priority will be spell checking features, and after that we are also planning to deploy this web search engine to any cloud server like AWS or Azure. Followed by that, we are also planning to go for the caching mechanism enhancement. As we already discussed, search engine must be faster enough to get the result so that user can like it. So we are planning on caching mechanism enhancement, followed by the word suggestion feature, which will be always useful to any client site. What will be the rules and responsibilities? So me myself, Jimish Shah, is working on the caching, health maps and documentation. Harsh has worked with the crawler, page rankings and sorting kind of features. Followed by the Vrunda will work on the UI, indexing and some of the AutoComplete features. These are some of the references which we have used during the development of the project and while working with the documentation part along with this PPT. Thank you so much for being patient and hearing us. If you guys have any questions, we would love to answer all of your questions. Thank you.